Today, we are going to solve question number 3. Find the longest substring without repeating characters. You are given a string S and required to find the longest substring without repeating characters. For example, this A, B, C don't have any repeating characters. So this is the correct substring. We only need to find the length of the longest substring. This one has 2 A's, so this is not a valid substring. The idea here is to check every single substring and check if it has any duplicates. If it doesn't, then return the length of the longest substring. So, how does the algorithms run? First, we start at A. We want to get every substring at A. So just this one, which doesn't have any duplicates. AB doesn't have any duplicates. A, B, C doesn't have any duplicates. Next, we get this duplicate A. Now we have 2 A's. But since we are checking every single substring, starting at this first A, we are going to keep this algorithm going until the end of the string. And every single substring after this is also going to be duplicates. So this is the repeated work. We are going to eliminate this with sliding window technique. So we just make sure that the substring in the window doesn't have any duplicates. Once we get this next A, we had 2 A's. We need to start removing from the left side of the sliding window and start shrinking the window until we no longer have any duplicates. So remove this A from the left. Now our substring starting from this B until A. The substring contains no duplicates and is valid. Next, we add this B, but the substring contains duplicate again. We remove this B from left, but the question is, how can we know instantly whether we had a duplicate or not? We can use a set. Set only contains unique characters, so we can know whether we have a duplicate. We put element into site and check new element against this site. We check this B against the set BCA and found B is a duplicate. We shrink the window from the left until we remove all the B's, and we are going to see that the first one we remove is the B. So our substring now runs from C all the way to this B. We are going to add another character C. Once again, we have duplicate. We shrink the window from the left until we remove all the C's. Now the substring is valid, no more duplicates. Next, we add B. Once again, we have duplicate. We shrink the window from the left again until we remove all the B's. We remove this A, but notice we still have 2 B's in our substring, so we got to remove another character B. So now our substring runs from C to B. Next, we add the last character B. It's a duplicate again. We shrink the window from the left until we remove all the B's. So we remove C, then B, and now we only have B in the site. Now we don't have any more element to check. The time complexity is big O n because we just have to go through all the elements from the site. Adding and removing the elements from the site is a quick action. The memory complexity is also big O n because potentially every character could be unique and will be added to the set. Now let's start coding. So we first get a set to store all the elements inside the window. The max length of result is assigned to 0. Next, we define a left pointer and right pointer to determine the sliding window. Left pointer will be initialized to 0. Right pointer will be continuously changing as we visit every single characters. So we define a for loop and right pointer will go through every single character. If we get to a duplicate character, we need to update our table. So while new character at the right pointer is already inside the set, meaning it's a duplicate, we need to update our window, so we have to take the left character and remove it from the set. Memo.remove left pointer. Increment the left pointer by 1. We're going to keep doing this while the duplicates remains in the set. After removing all the duplicates, we can add this rightmost character to the set, since we know for sure our string doesn't have any duplicates. We can potentially update our result by taking the maximum of result and current window size. Current window size can be calculated by right minus left plus 1. At the end, once we have gone through the entire string, we can return the result. As you can see, the time complexity is quite efficient.